Have you ever wondered what the universe is truly made of? What if everything you see around you, every star, planet, and even you, wasn't made of particles but tiny, vibrating strings? Sounds impossible, right? But string theory proposes just that. The idea that the fundamental building blocks of everything are one-dimensional strings, vibrating in ways we can barely imagine. What if this theory could explain everything, from gravity to the forces that govern atoms? In today's video, we'll dive deep into string theory and explore its mind-bending concepts. So, are you ready to unravel the mysteries of the universe? What is string theory? Imagine for a moment that the entire universe, everything you see around you, is not made of solid particles, but rather something far more mysterious. What if, at the most fundamental level, everything, from the tiniest atom to the vastest galaxy, is made up of tiny vibrating strings? That's the essence of string theory, a revolutionary idea that suggests the basic building blocks of the universe aren't particles like we've always thought, but these minuscule one-dimensional strings. Now let's break this down. Picture a guitar string vibrating. Depending on how it vibrates, it produces different notes, right? Well, according to string theory, the vibrations of these strings determine the properties of particles like quarks and electrons, particles that make up everything in the universe. These strings are unimaginably tiny, so much so that they're smaller than even atoms. And just like different vibrations on a guitar string produce different sounds, the different vibrations of these strings give rise to all the different particles and forces that govern the universe. It's a bold claim, isn't it? It challenges everything we've been taught about what makes up the fabric of reality. But what's fascinating about string theory is that it brings a fresh perspective. If we could understand how these strings vibrate, it could be the key to understanding everything. The forces that bind atoms together, the way particles interact, even the force of gravity itself, all of it could be explained by the behavior of these tiny vibrating strings. So let's journey deeper into this world of strings and see how they could change our understanding of the universe. The four fundamental forces. We all experience the world through the lens of four fundamental forces. Gravity pulls everything downward. Think of the apple falling from the tree. Electromagnetism is what makes your phone light up, or a magnet stick to your fridge. The strong nuclear force holds the nucleus of atoms together, and the weak nuclear force governs radioactive decay. But here's the thing. Even though these forces shape everything in our universe, they don't fit neatly into the same framework. Each of these forces operates on different scales, with different rules. Gravity works on large scales, holding planets and stars in place, while electromagnetism governs the behavior of charged particles like electrons. The nuclear forces, on the other hand, are confined to the tiny space within atoms. But what if they could all be part of the same system? String theory suggests exactly that. These forces may have once been unified, existing together as a single force right after the Big Bang. It's a mind-blowing thought that these forces, so different in how they act, might have all come from the same source. String theory proposes that at very high energies, like those just after the birth of the universe, these forces were united in a single, elegant force. As the universe cooled, they separated, and over billions of years evolved into the four distinct forces we observe today. But here's where it gets exciting. String theory doesn't just unify these forces, it could potentially explain why they operate the way they do. If we could understand how they evolved from 1 to 4, we could unlock answers to some of the most profound mysteries in physics. Could string theory be the key to this unification? That's the question scientists are trying to answer today. Unification of forces. Imagine this. All the forces of nature, the ones that govern everything from the tiniest particle to the largest galaxy, could at one point have been unified, existing as a single force. It sounds like science fiction, but it's a real possibility according to string theory. The idea of force unification suggests that, in the early moments of the universe, right after the Big Bang, gravity, electromagnetism, and the nuclear forces, strong and weak, were not separate entities as we know them today. Instead, they were part of a singular force that existed in harmony, working together as one. Now, picture this force like a tightly wound spring. As the universe began to cool and expand, this single force began to stretch out, cooling down and splitting into different forces over time. So gravity, which governs massive objects like planets and stars, separated from the electromagnetic force that powers electricity and magnets. Similarly, the strong nuclear force responsible for holding atomic nuclei together, and the weak nuclear force responsible for radioactive decay, broke off from each other as well. What string theory proposes is that if we can uncover how these forces were unified, we might understand not only the origins of the universe but also a deeper connection between everything that exists. All of the laws that govern the universe could have come from this one unified force. The theory also suggests that, under extreme conditions like those found inside black holes or in the first moments of the universe, these forces might merge again. If we could access that information, we could potentially create a theory of everything, unifying all the forces of nature into a single framework. Could string theory hold the key to this ultimate unification? That's the journey scientists are currently on. Extra dimensions. String theory isn't just about small strings vibrating in a big universe. It takes us beyond the familiar dimensions of space and time. You see, we are accustomed to thinking in terms of 3 dimensions of space: up, down, left, right, and forward, backward, and 1 dimension of time. But in the world of string theory, that's just the beginning. To make sense of how the theory works, we need to accept the existence of extra dimensions, dimensions beyond the ones we can see, feel, or even imagine. Now don't panic. These extra dimensions aren't something you can just walk into. In fact, string theory proposes that these extra dimensions are compactified. They're tiny and folded up in a way that makes them undetectable with our current technology. In essence, these dimensions are hidden from our everyday experience, existing at scales so small that they're invisible to even the most powerful microscopes. But why extra dimensions? Well, it turns out that these dimensions are critical for string theory to be mathematically consistent. Without them, the strings wouldn't be able to vibrate in a way that explains all the particles and forces in the universe. Some versions of string theory even propose that there could be as many as 7 extra dimensions beyond the ones we know. These dimensions might be compactified in shapes called Calabi-Yau manifolds, fancy terms for the intricate geometric shapes that these dimensions could take. But while we can't see or directly interact with these extra dimensions, they could play a huge role in how the universe operates at its most fundamental level. If we could somehow uncover more about these hidden dimensions, it might unlock some of the deepest mysteries of physics, leading us to a fuller understanding of everything that exists. Supersymmetry. Imagine a world where every particle you know, every quark, electron, and photon, has a mysterious twin, a superpartner. This is where supersymmetry steps in. It's a concept within string theory that suggests that for every particle, there's a corresponding particle with different spin properties, often referred to as its superpartner. At first, it sounds a bit like science fiction, like something out of a superhero movie. But supersymmetry isn't just an intriguing idea, it's a crucial piece of the puzzle in string theory. You see, the fundamental particles we know today don't quite fit into the elegant equations that describe string theory. Enter supersymmetry, which smooths out some of these inconsistencies and helps bring string theory's predictions into alignment with reality. Now let's dive a bit deeper. Every particle in the universe has a property called spin, a fundamental characteristic that affects how the particle behaves in relation to other particles and forces. Particles like electrons, which are fermions, have half-integer spins, while force carriers like photons, the particles of light, are bosons with integer spins. According to supersymmetry, each fermion has a boson counterpart, and each boson has a fermion counterpart. This pairing helps to balance out equations and resolve some of the mathematical problems in string theory. While we haven't observed these superpartners yet because they're expected to exist only at very high energy scales, far beyond current technological capabilities, the idea of supersymmetry provides an elegant way to potentially explain some of the gaps in our understanding of the universe. If supersymmetry holds up under experimentation, it could open new doors in understanding particle physics and even the elusive concept of dark matter, the invisible substance that makes up a huge part of the universe's mass. Supersymmetry could very well be the key to unlocking mysteries we've been chasing for decades. Challenges and criticisms. As mesmerizing and elegant as string theory sounds, it's far from perfect. In fact, it faces a number of challenges and criticisms that have made many scientists hesitant to fully embrace it. And the biggest issue? The lack of experimental evidence. For any scientific theory to be accepted, it needs to be testable, something that can be observed, measured, and verified. However, string theory operates on such a small scale, far beyond what we can currently observe. The energy levels required to test the predictions of string theory are so high that even the most advanced particle accelerators, like the Large Hadron Collider, cannot reach them. This means that right now, we don't have a way to directly test whether string theory's predictions hold up in the real world. But that's not the only hurdle. Another criticism of string theory is the vast number of possible solutions it proposes. Depending on how you interpret the theory, string theory could describe an almost infinite number of possible universes, each with its own unique set of physical laws. Some critics argue that this makes string theory more of a mathematical framework than a truly predictive theory. Essentially, it's so flexible that it can explain anything. This makes it difficult to pin down a definitive prediction that could be tested. And then, there's the complexity. String theory involves highly advanced mathematics. Sometimes it feels like we're using abstract equations to describe things that we can't see or touch. For many, it feels more like an intellectual exercise than a practical theory that could be tested. Some even argue that scientists are chasing something that may never be testable, leading them away from more immediately fruitful areas of research. Despite these challenges, string theory continues to inspire physicists. The elegance and potential of unifying all forces into a single framework still resonate with many. And though we may not have all the answers now, the journey to understand the universe on its most fundamental level could take us to new frontiers of physics. Whether or not string theory becomes the ultimate theory of everything remains to be seen, but the pursuit of it is, without a doubt, an exciting chapter in the story of science. And that's a wrap on today's dive into the fascinating world of string theory. While it might seem like something straight out of science fiction, it's a theory that could change everything we know about the universe. What do you think? Could strings be the key to understanding the forces of nature? Let us know your thoughts in the comments below. If you enjoyed this journey into the unknown, don't forget to like, share, and subscribe for more amazing space facts. Until next time, keep looking up because the universe has so much more to reveal.